Well, hello, everybody. So exciting to be here. I am David Falconer. I'm the founder and executive director of Classrooms Without Walls. And I have here with me both Artem and Anastasia from Smartos Vida. And start of the day, Bob MacDonald coming all the way from BC, right? British Columbia.
Yes, I'm on the west coast of Canada right now in British Columbia.
Well, so good to have you, Bob. We had Bob over a year ago, and he left such a huge impression on everybody. In Canada, Bob is known by millions of people. When I go home or when I'm driving somewhere, it never fails because I listen to CBC radio. Bob's show, known as Quirks and Quarks, is heard by hundreds of thousands of people on a weekly basis. And it just never fails to entertain and educate individuals. So, Bob, thank you very much for being here. Your presence means a lot to us. It just sends a message that you are thinking about all these children that are living in conflict zones. And your message will be one of hope, but also of knowledge. And we look forward to being, taught by you today. So thank you.
Well, thank you, David, and thank you very much for inviting me to do this. And thank you, everyone who's joining us today from around the world. I happen to have the world with me here today, and I was thinking about where we all are right now. So here on this, I hope you can see this. Here on the globe, there's Africa, and just up here, just north of Africa, is Ukraine. Over here is continent of India, and Afghanistan is just here. And over here is Myanmar around here. And if you keep going all the way across the Pacific Ocean, over here, you come to North America, and I am here. So on the West Coast. So we are covering the entire world right now. It's really quite amazing that we can do this through this miracle of Zoom, and it's just wonderful. And I also thought it is 8 o'clock in the morning for me, and you might be interested where I am. This part of Canada is very rocky. We have a lot of mountains here, and I'm not at home at the moment. I'm actually in a place that's in the mountains. And just to give you an idea of what it looks like outside where I am right now, we have very thick forest here. I am completely surrounded by these trees. These are pine trees, and they're very, very tall. And this is our rainforest. This is what we have here on the western part of Canada. So it's quite a different environment that each of you is in right now. I know that. So we represent planet Earth right now. We represent planet Earth. And I find that kind of neat that we're doing all of that. So my presentation today, let me just share my screen with you and see if we can make this happen, is called Perspectives on a Planet, because that's what we live on, is our planet. So let me just see if I can make our technology work here. There we are. See if I can share this. Just hang on. Let me get... Oops, sorry, too far. There. Can you all see that? Are we good? So, perspectives on a planet. And I've been very fortunate in my life to explore a lot of this planet. And I hope that at some point in your lives, you'll have an opportunity to explore some of it and go see what this world looks like. When I was in my late teens, I went all the way around the world by myself just to see what it looks like. And it was the best thing I ever did. So I hope that at some points in your lives, you'll have a chance to explore even just a little bit of it, because this planet is very special. And I also had another experience where I was able to feel what it's like to walk on another planet. Two of them, actually. I got to experience what it's like to walk on Mars, and I got to experience what it's like to walk on the moon. Now, I didn't go to Mars and I didn't go to the moon, But what I did was fly in a very special airplane. It's the kind that's used to train astronauts. And it's a big airliner with no seats in it. And the walls are all padded. And they fly the airplane up and down like this. And every time they go over the top of the hill, you become weightless inside and you float around like an astronaut. And it was really cool to be able to do that. I have a short video I'm going to show you. And then when it goes down and they pull it up, you feel 2 times your weight as you pull up like this. So you go from twice your weight to no weight to twice your weight to no weight. And we did this 15 times and it was just wonderful. Now, what's special about it is that the first time they did not go right to 0G. That's right now you are experiencing 1G, which is the Earth. That's the gravity holding you down. But the pilots can control how much weight you lose. And on the first one, we only lost 2/3 of our weight. We went down to 1/3, which is the gravity of Mars, because Mars is smaller than the Earth. So you don't weigh as much on Mars. On the second one, they went to 1/6 of a G, which is the gravity of the moon, which is really, really light. So let's, I'll just play this. It's pretty silly, but let's see if this works. And hopefully the sound will work on this as well. Here we go. Can you hear that?
Not really.
Are you, oops, sorry. Are you hearing the sound?
No, no.
All right. I think I have to do something for share screen with sound. All right. I will talk you through it then. I will just a minute. All right. I'll talk you through it. Oops, sorry. Let's try one more time. This is where technology fails me. Okay. So this is the 0G airplane taking off. And when a plane is flying in a straight line, you feel 1G, just like we do here on the Earth. But when we start flying up, hump pattern like this, and here's the gravity of Mars. We're lying on our backs, and then we just get up, and I'm kind of giggly here, jumping around. This is walking on Mars. And I feel really light, very light on my feet. So when we go to Mars, you will walk differently. You'll walk like you're on a trampoline or something. So here we are, 1/3 of our gravity on Mars. Walk like a Martian. Okay. Okay. So now we get back on the floor and the pilots are now pulling up and they're starting to go over the next hump. Here we go again. This time it's a steeper hump. And now we feel even lighter. Here's the gravity of the moon. Now watch closely. I take a jump up, woo, and I come down slowly. I feel super light now. Isn't that crazy? Now I'm going to see if I can do a flip. I'm going to try to do a backflip. Watch. Woohoo! Hey, that was easy. And then finally they go really, really steep and I start to feel no weight at all. So here I am floating around just like an astronaut on 0G, and it's really, really cool. And I'm trying to control myself, but when you're floating around like that, it's really hard because you're not touching the walls or anything. Throw the ball. And now we're going through the bottom once again, and I'm starting to feel heavier. I'm getting heavier and getting heavier. Twice our weight now. 2 times our weight. Wow. Okay, here we go. One more for 0G. Over the top. Hey, look at me. I'm just like an astronaut floating in space. And what I'm going to try to do now is throw a ball. There's a ball floating by. See if I can grab it. But I couldn't get to it. Everyone's just floating around. And here's my stunt. Imagine doing this. Isn't that crazy? Woohoo! Ugh. Anyway, that was pretty cool. That was pretty cool. And so what I found was that in zero gravity, when you're floating around like that, you have no way to control yourself. So you have to go very, very slowly and just use your fingers and your toes to plan where you want to go. So I got the closest I'm ever going to get to going into space. But this fellow did go to space, and I had the opportunity to meet him a number of years ago. His name is Bill Anders. And before all of you were born, he went to the moon. And he was on the very, very first mission to the moon. And they didn't land, but they just went there. They went around the moon a few times, and then they landed. And he was the person who took this picture of the Earth. And it was the first time that we saw the Earth from another world. Humans had never seen the Earth like this before. People who go into space now don't see the whole planet. They're too close. They only see sort of the curve of the Earth, but they don't see the entire planet. So it was only those 24 people who went to the moon in the 1960s and the 1970s who got to see this. And when I asked him about it, I said, what was it like to take this picture? He said, we were not even supposed to take it. We were there to look at the moon. We were to photograph the surface of the moon, not the Earth. And so he said it was a surprise. They were going around the moon and the Earth came up and they went, wow, look at that. Take a picture. And he said it was very, very small from the moon. When you look at the Earth, you can hide it behind your thumb. You can hide the Earth behind your thumb when you're on the moon. So the Earth is very tiny. It's very tiny. And you'll notice the moon, it doesn't have any air. That's why the sky is black. There's no air there, but there's air here. You can walk outside. You don't need a spacesuit. But on the moon, you have to wear a spacesuit all the time because there's no air. Black sky. It's a deadly, deadly place. The moon will kill you if you don't wear a spacesuit. There's radiation from the sun, no air to breathe. It's really not a very nice place. But here, our beautiful blue Earth, we can walk around and be fine outside. So this was a big wake-up call for us that our planet is small in a very big, dark, violent universe. And unfortunately, Bill Anders, here he is just a week ago. He's 90 years old now. And unfortunately, he died when he flew this airplane. He crashed. He was performing stunts. He was performing stunts on his airplane and it crashed. So we lost Bill Anders last week. But he was a very significant astronaut who showed us what our planet actually looks like. We have a Canadian astronaut who's going to go to space. He's going to go to the moon as well, hopefully next year. His name is Jeremy Hansen. And he's going to go even farther. He's going to go on a huge rocket, one of the biggest in the world, and he's going to go past the moon. So he will see both the moon and the Earth out the window. That's never been seen before. But look at how small they are. Even the moon and the Earth, they're tiny. We just live on this tiny, tiny, tiny little world. Well, some people think we're going to go to Mars as well. The largest rocket in the world called Starship. And you can look this up. Elon Musk is building the largest rocket in the world. And he thinks that he's going to use this rocket to take people to the moon. They're going to land on the moon and build a colony there and work again in the future. Not just go there for a visit. They're going to go there to live. And they'll have to build their colony underground. They'll have to cover it in dirt to protect it from the sun because the sun is very, very bright and dangerous on the moon. But this is the future. Over the next 10, 15 years, we're going to be building colonies on the moon and people are going to go there to live. But they will always have to wear a spacesuit when they go outside because the moon is such a deadly place. And then Elon thinks that he can use his Starship to take people to Mars and they can experience that low gravity just like I did. And he wants to build a Mars colony there. But even on Mars, even though there's air on Mars, it's not like our air. The moon on Mars doesn't have any oxygen. It's all carbon dioxide. You cannot breathe on Mars. So if you're going to go for a walk on Mars, even under that low gravity, you have to wear a spacesuit all the time. Mars is also very cold. It's even colder than we are here in Canada. It's minus 20 degrees during the day, minus 20, minus 30, and at night, minus 90 degrees. Super, super cold on Mars. So, yep, people will go there, but it's going to be hard. It's going to be hard to live when we go to Mars. They'll have robots there. They'll go around and do experiments, but it's a cold, dry desert with a pink sky, not a blue sky like we have, because there's so much dust blowing around on Mars. There's good skiing there, though. If we like to ski in Canada, and at the North Pole of Mars, there's snow. So we could go skiing there. But again, you'll have to ski in a spacesuit. You have to have a spacesuit with skis. I'm not quite sure what that would be like. But anyway, and there's another world beyond Mars that has ice. It's not a planet, it's a moon. And there's a robot that's being sent there next year called Europa Clipper. And this moon of Jupiter, called Europa, is covered in ice. And the reason we want to go there is because underneath the ice is an ocean. And they think that maybe there's a whole lot of water on this moon. In fact, more water than we have here on Earth. And they want to find out maybe there's something living in there. So there's another moon that goes around Saturn. Same thing. It's covered in ice. And they believe there's an ocean underneath it. Imagine that, a moon with an ocean, a moon with an ocean. And this moon of Saturn, the ice is cracked, and the water's coming up into space. And we flew a spaceship right through that ice plume, and we found that there are chemicals in it. And the same chemicals that are on this moon, we find at the bottom of our ocean here on Earth. Deep, deep in the ocean, there's hot water that comes out of the bottom. And there's life that lives around these hot water vents. Worms and crabs and clams. Some people even think this is how life started on Earth. So could there be this kind of life on these moons of Jupiter and Saturn? We don't know. But if we're going to find alien life, maybe that's where we have to look, not on Mars. So it's kind of exciting that we're going to start exploring these worlds right here. Now, we also found that there are planets that are going around other stars. So we're now up to almost 5,000 planets. 5,000 planets that we have found going around other stars. And some of them seem to be like the Earth. They're similar size, and they're in what's called the Goldilocks zone. They're not too close to their star, and they're not too far away from their star to be either too hot or too cold. They're just right. And whenever this happens, we get all excited. Ooh, maybe there's water there. Maybe there's life there. Maybe there are aliens on these worlds. And we start thinking like we do with our science fiction movies, that, ooh, we can go to these planets and meet all these aliens. Well, it turns out these planets are not like that. In science fiction, in our movies, we always make the planets really nice when we land. It's a nice day, and all the aliens speak English. Well, they don't. That's not what it's like. The universe is very, very different. And what we're finding is that these other planets that we have are quite different from us. They're very, very close to their stars. They're super, super close to their stars because the stars that they go around are not like our sun. Our sun is big and bright and gives us lots of heat and light and everything. The stars that these planets go around are very small and dim. And when the planet is super close to a star like that, one side of it will always be facing the sun. So it'll be like a desert. It'll be super hot. The other side will always be facing away from the star, so it'll be super cold, like Canada in the wintertime, or the South Pole in the wintertime. So one side's always dark, one side's always light. It's not like the Earth at all. I don't know what kind of weather we would get on this or what kind of life could live there, but they're very, very different worlds than what we have. We have yet to find another Earth. And we live in a huge, huge galaxy with billions of other stars and probably trillions of other planets. But we can't go there. We can't visit those other worlds because our spaceships are too slow. It takes hundreds of years at the way we have now to go to other stars. And they're so far away. If you wanted to go from where we live in our Milky Way to the middle, to the center there, where there's a giant black hole, it would take you 30,000 years at the speed of light. And we can't travel anywhere near the speed of light. And if you wanted to go to the other star, the other side, it would take you 100,000 years at the speed of light. So we're kind of stuck here on our little planet in our corner of the galaxy until we develop better spaceships. We just don't know how to do that. So here we are on our little planet. And I met the guy who took this picture too. This was the last picture of the Earth taken by a human being holding a camera in their hands. And look what's in the middle, the continent of Africa, where we all came from, where we found our oldest human ancestors, where stone tools were first made 2 million years ago. That's where humans first stood on two legs, right in the middle of that picture. And now we've got the technology to take a picture of ourselves from a distance. But this planet, it's not very large. We think we have, here's the Earth. Can you see the Earth up there in the corner? That's how we compare to the sun. We're tiny. We would be eaten by the sun if we were closer to it. So we're a little tiny, tiny little speck. We might think the Earth is big compared to us, compared to humans, but we're actually really, the planet is very small. If you were to take all the water on the Earth and put it into one drop, that's what it would look like. That's it, that big blue drop. And I want to show you something. Just give me 1 second here. Don't go away. I'm just going to show you something. Can you see me? Not if you can see me. Can you? Yes, you can see me as well as the picture?
Yeah, we can.
Okay, just don't go away. I'm just going to get a glass. Okay, hang on. Just 1 second. Okay, I forgot to set this up ahead of time. Sorry. Okay. Here's something that you can think about, a little trick you can play on a friend. Let's suppose that this glass is all the water in the world, and I represent all the people in the world, and we're over 6 billion of us now, right? So how much water in the world can we actually drink? Well, let's say I'm humanity. I want to take a drink of water. Well, actually, I can't drink most of the water in the world because it's salty. It's in the oceans. I can't drink salt water. So of all the water in the world, how much do you think is salty? What do you think? Quarter? Yeah, more than that. Half of it? More than that. 3/4 of it? More than that. There. About 90% of the water in the world is salty. So there's the fresh water in the world. That's the kind of water we like to drink. Okay, so I'm going to have a drink of fresh water. No, I can't drink most of the fresh water in the world because it's frozen. It's down at the South Pole in Antarctica. It's at the North Pole. It's in our glaciers in the mountaintops. So I have to take away the ice. Most of the water in the world is fresh water is frozen. So how much do you think is frozen of all the fresh water in the world? Half? More than that. About 90%. So there's the liquid fresh water that's in the world for us. Okay, I'm going to have another drink now. The liquid fresh water. I have to take away some more. There's water that we can't get to. It's deep underground. They're called aquifers. Can't get to that, so I got to take some of that away. Nope, there's still some more that I can't get to. It's in the plants, the trees. All the plants have it up in their stems and their leaves, so I have to take that away. They're using it. And one more. There's water that's in the air. It's in the clouds. It hasn't fallen yet as rain, so I have to take that away. So after I subtract what's in the clouds, what's in the plants, what's deep underground, what's frozen, and what's salty, I have the water in the world that's for all of humanity. The water that's in our lakes and our rivers and our shallow groundwater when we dig wells. And out of this glass, what do I get? Come on. Oh. One drop. One drop out of a glass. That's all we have. That's all we have here on planet Earth. And that's why we have to take care of our water, because we don't have a whole lot of it to drink. So let's not put our garbage into our water, because there really isn't as much as we think. So we have a small planet. We don't have a lot of water on it. And if you were to say how thick is our air, cut an apple in half. And the skin of the apple is how thick our atmosphere is. It's very, very thin. So this is it. This is our planet. Here we are. This beautiful planet of ours. It's blue, it's brown, it's green. It's the only one we know of. This is all we have. We can't go visit other planets. We're stuck here. So that's why we have to take care of this one as best we can. People sometimes ask me, what's your favorite planet? This one. There's nothing like it. So just thought I'd let you know that the perspective on this planet. Go outside wherever you are and try to find a piece of nature. Go look at a tree, go look at the grass, go look at whatever is alive that you can see, and really have a close look at it, because we don't know of any other planet yet that there's life. And if there is another Earth out there, it's going to be so far away we can't get to it. So this is it. Let's enjoy our planet Earth. So that's what I wanted to say to you today. And I will see if I can stop my sharing here. And does anybody have any questions that they would like to ask me? You'll have to turn on your microphones if you're going to do that.
Yeah, let's talk to someone, but I just want to ask you guys, please, can you ask only like 1 or 2 questions, not a lot, so that more people could talk, and make sure that your question accords our topic of our class. Thank you. So let's talk to Gregory firstly.
Will our planet die?
Will our planet die?
Yes.
Yes, it will, but not for a long time. Our planet will die when the sun dies. The sun is going to come to its end about 4 billion years from now. 4 billion years from now. And before it dies, it's going to go bigger and bigger and bigger. And eventually it will surround the Earth. And that's when we will die. But it's not going to happen for a very, very long time. So we can take care of it until then.
Goodbye.
Thank you. Thank you for that. That was a good question.
Yeah, thank you, Gregory. Then Seema and Nadia.
Well, if without sun, the Earth won't stay alive. So keep our planets and stay safe.
Yes. Without the sun, we would be very, very cold. We would be covered in ice like those moons that I showed you. That's what the Earth would look like. We'd be totally frozen. So say thank you, sun. Sun gives us everything. Sun gives us life.
Thanks for your question, Seema and Nadia. Then Kira.
Can some plants on the earth drink salt water?
Can some plants drink salt water? Yes, there are lots of plants in the ocean that do salt water. Seaweed is underwater. Kelp is underwater. So there are lots of plants that drink salt water, and some that live along shorelines that are in swamps, and they can drink salt water as well. We can't. We cannot. We have to drink fresh water. If you drink salt water, you get very, very sick. We have to get rid of our salt. We have salt in us, but we're always getting rid of it through sweat and when we pee. So we have to drink fresh water ourselves. We can make fresh water out of salt water, and some parts of the world do that, but we can only drink fresh water. Yeah.
Okay, thank you for the lesson.
Oh, it's not the end of our class yet, but thank you, Kira. Then, Maggie?
Yes. So, if we were to like start a colony in any other planets and we couldn't like adapt to the environment in it, would it be like possible for our anatomy to change so that we could adapt to whatever environment is in it? And if we were like physically able to do that, were there like any changes that we have made with our body within the past years of the human evolution?
Wow, that's a really good question. I've thought about that. And if people live on Mars permanently for a long time and babies are born on Mars, they will be born under less gravity than we have here on Earth. So they may not have as many muscles as we do. They won't need muscles, as big muscles. So they might be quite thin. And they will be used to walking differently. That will be natural to them. So they'll take bigger steps, and that'll be their way of walking. And if they come to Earth, they would find it very difficult here. They'd find it hard to walk around because they'd feel so heavy. So yes, the body does adapt to other environments, but we would not adapt to living on carbon dioxide. We would still have to breathe oxygen. I don't think we would turn into breathing a different kind of atmosphere. I think we would always need our oxygen and our water. But physically, we might look different, yes, if we go to different planets. Yeah.
Just one more small question, if you don't mind. Like we see these like representations of like Martians, like fictional Martians with like these slender figures and like the big hat. Are they like scientifically accurate?
That's just from science fiction. It's just become a thing that people like to associate, but we have no evidence of what alien life might be like. I mean, I've even thought of people who live in space all the time. They don't live on a planet. Suppose they're always floating freely, like I was in that airplane. If you never touch ground, if you never experience gravity, your body would completely change. Who knows? You don't need legs. So maybe over millions of years, our legs would fuse together. We'd look like dolphins. And we'd just be all arms. I don't know. Maybe there would be a new species of humans that I like to call Homo spacians. And who knows what we would look like. But it would take a very long time for our evolution to change. But the little green men with the big heads and the big eyes, we have no evidence that that's what they'll look like. I think that when we do contact aliens, they're going to look very, very different from us. They won't look like one head, two arms, two legs, and speak English. They might look very, very different. How would you feel talking to something that looks like an octopus or something that looks like a plant, but it's smart? That's going to be hard when we contact aliens that look very, very different. And they will find us very different too. Those are all interesting things to think about.
Thank you.
You're very welcome.
Thank you, Maggie. Bob, would you like to answer some more questions?
Sure.
Or...
I've got time if you do.
Yeah, sure. So, Vladislav?
Oh, yeah, thank you. I wanted just to make a small clarification because you said that the gravitational acceleration on Mars is less than on Earth because of the smaller side on Mars. But this is not quite true because the gravitational acceleration is inversely proportional to the square of the radius of the planet. So the smaller this radius, the greater its g. Yeah. So therefore, Mars g is smaller than Earth because of Mars' smaller mass and density.
Yes. No, I agree. I just use the word smaller as a generic term. I understand totally that it's because of mass. Mass and g go together. That's exactly what. No, you're exactly right. So thank you for the clarification. I do understand that. When I'm speaking to the public, I use more general terms just for better understanding. But thank you for that.
Thank you, Vladislav. Then Igor?
Firstly, I want to thank you for the lesson. I really like it, and I want to ask you: can can people make a space suits to go like so the astronauts can go more easy, not like a robot, a jumping robot.
Yes, they are designing new spacesuits for exactly that reason. The spacesuits that they have now, that they use up on the International Space Station, are very big and bulky and hard to move, but they're floating all the time, so it's not so important. But they're designing new spacesuits to go both to the moon and to Mars. They're much more flexible and lighter so that they can move around more easily, and they can walk and they can run.
But if it will be lighter, they will be jump more higher.
Yes, they will. Yes, they will be able to jump higher.
So to Phobos, they don't will go. So they don't.
Imagine the Olympics on Mars or the Olympics on the moon. The high jump will be much higher than it is here. And basketball, you play basketball on the moon, you can shoot really high.
So
sports
it will be 100 meters up this basket.
Maybe. Maybe. That's 100 meters is a lot, maybe 30 meters. But yes, everything will be different when the gravity is different. All sports will be different. It'll be fun.
And football gates will be 10 meters high.
Now if you're on the moon and you have a very large building with air in there, and you don't need to wear a spacesuit, just like you're inside right now, if we build that on the moon, then you can have indoor sports. Then you can really jump around and have a good time. Yeah, I look forward to that.
Yeah, thanks for your question, Igor. The next one is Amina.
Hi. First of all, I wanted to thank you from all of us for this lecture and for answering to our questions. Yes, and I wanted to ask you, how do you think, is that the opportunity that aliens will find us or contact with us? What do you think?
I think that's a very good possibility. I don't think it has happened yet. I do not believe in UFOs. I don't think they're here floating around in our atmosphere, teasing us. We have no evidence that they've come in the past, but if they do, we are going to go through huge culture shock because they will be very different from us. And we will have to learn how to communicate with them because they won't speak Ukrainian or English or anything like that. We will have to find out how to communicate with them. And I'm hoping that when they come here, we don't try to shoot them, that we let them come and teach us. But that will let us know that we are not alone in the universe, and that will be very profound. So I think it will be a big turning point in humanity. We will be humbled. They will know so much more than us. They will know how to travel in space. They will, and we can learn from them a lot. But communication is going to be very tricky at first. But once we establish that, I think we can learn a lot, and we will be humbled. We will be humbled to realize that there's so much more out there than just us. Maybe that will bring us together.
Maybe.
That would be nice. That would be nice.
Thank you so much for sharing your thoughts.
Thank you for joining us today.
Yeah, thank you, Amina. Then the next one is Sophia.
Well, I have a question. Is it able to happen that there will be no air in our planet?
I didn't quite get that.
Can it happen that there will be no air on our planet?
No, we will always have air. The air, we do lose air to space. The sun does burn some of our air off, but we always get new air from volcanoes, believe it or not. The air comes from inside our planet all the time. It's like the Earth is breathing out. There are gases trapped inside the Earth, and every time a volcano erupts, it replenishes our atmosphere. Now, what volcanoes give us is mostly carbon dioxide, but plants turn that into oxygen so that we can breathe it. So we're always getting new air. If volcanoes stop, then we could be in trouble. And that's what they think happened to Mars. Mars used to be more like the Earth. It was warm, it had lakes and rivers, maybe even an ocean, and it had a thicker atmosphere. And it's got some of the biggest volcanoes on any planet we know of. But those volcanoes went quiet and they no longer put up. And so on Mars, the air burned off into space. So now the air is very thin and it got very, very cold, and all the water froze underground or blew off into space. So at the moment, the Earth is in good balance. We have the volcanoes giving the air out and keeping it replenished, and our relationship with the plants, both on land and in the ocean, that turn that carbon dioxide into oxygen. So we're very fortunate here.
This was really interesting because I didn't know this information before. Thank you.
You're welcome.
Thank
Let me
so
tell you
much.
something. Let me tell you something else about the water that we have. It's the same water that the Earth has always had. We don't get new water. The water that we have came out of volcanoes. They also give us water, but also from objects that fell from space, comets and asteroids that contain ice. And they fed us early on when the Earth was new. We were hit by a lot of objects that gave us this water. But since then, it's been recycled over and over and over again through the water cycle. It goes up into the clouds, floats around, falls down as rain, floats around on the Earth and goes back up into the clouds again. And it keeps going up and down and up and down and recycle. So this water that I have right here, this water has been through a dinosaur. This water's been through a dinosaur. So think about that next time you take a drink. We're very lucky that the water, when it goes from the ground up into the sky, it cleans itself. It cleans itself up, so rain comes down clear. That's why it's very important we don't put our garbage into the water. Keep it clean.
Yeah, thank you, Bob. Then can I ask some more people, right?
Mhm.
Okay, so the next one is Leonid.
Well, that it was very interesting. I would ask you a question. How do you imagine the moon in 2034 year?
The moon will have people on it, and most of the people will be at the South Pole, the bottom of the moon, because they think there's ice there underground. And ice on the moon is very valuable because it provides drinking water for astronauts and cosmonauts who go there, and taikonauts, the Chinese. But it's also rocket fuel because water is made of hydrogen and oxygen. And when you break it apart, you use that as rocket fuel to go other places. So I think we will see colonies at the South Pole of the moon, and we will see, I'm not sure how many people will be there, but we'll have people. There will also be a space station around the moon called Gateway, that people will be living there and going up and down from the moon to the space station. So it'll be a busier place. But from here, where we live, when we look up at the moon, it'll still look the same because you can't see people from here on the moon. They're too small. But it'll be busy down at the South Pole.
Okay, thank you for your
You're
opinion.
welcome.
Goodbye.
Okay. Bye.
Thank you. Then the next one is Victor.
Yep. Hello. I'm really happy to see you now.
Well, thank
And
you.
I want to ask you about time because, as I saw before, I thought that it would take decades for us to start this life on other planets or the life on the moon. But after now, I could understand that the changes are happening fast, and maybe after some years we will we will possibly travel to other planets. What do you think about it?
Well, we will only travel to planets that are close to us, like Mars. And of all the planets in our solar system, the ones that go around the sun here, Mars is the only one, and the moon are the only ones that we can really visit, because the other planets are either too hot, we can't live there. Venus, Mars, or Mercury are too hot. And the big planets, Jupiter, Saturn, they're made of gas, and they're poisonous, and they're very, very far away. It takes years just to get to those. So if we want to go to planets around other stars, we need a different kind of spaceship, because our rockets right now are way too slow. The largest or the fastest spaceship that we've sent out is called Voyager. And it's now beyond Pluto. It's out among the stars. I was at the launch of Voyager when it took off from Earth. Get this, in 1977. 1977, I watched Voyager take off. And back then, my hair was black and it was down to here. So look what's happened to me. Just since Voyager took off, I've gone gray and I've gotten old. And we're not even close to another star. It's going to take Voyager thousands of years before it gets too close to another star. So our spaceships are so slow, it takes longer than a human life to go anywhere. So we need something that's super, super fast, and we don't have that yet. People are working on new kinds of rockets, but until we develop something really fast, or something like Star Trek that can go faster than light, we're stuck here. We're stuck here. We just can't do it. So we're too slow. So when maybe you will invent something faster and get us out to those planets quicker. But for now, we're stuck here.
Yeah, we'll see. Thank you a
Work
lot
on
for your
that, okay?
answer.
Okay,
Yeah, it was really interesting. Thanks a lot.
thank you. You're welcome.
Thank you, Victor. Then Dmytro.
I have got a little question to you. What if gravity on Earth was like gravity on Moon? Our planet will be still alive, or our planet will be die?
If we didn't have the moon, is that your question?
No, is if we have gravity like at Moon.
Oh, if we had gravity like the moon on Earth, we could still be here. Our atmosphere might stick a little further out into space. Everybody would feel lighter, but well, I think we could still adapt. It would be easier to get around. But the Earth would have to be smaller to, or less massive than it is now to do that. If we had if the Earth wasn't as large as it is right now, I don't know. That's a good question. If the Earth was like the moon, we would be like the moon. We wouldn't have as much air or water. So it's good that the Earth is the size that it is. We need it to be this big to hold on to our water and our air. Yeah. That's a good question. You know, that's a very good question. Maybe think about that. Waves on the ocean would be
Thank you
different,
very much.
much bigger. Yeah.
Yeah, thank you, Dmitra. Then Anastasia.
So my very interesting in your lesson. My very interesting listening about in the future planet Earth. This is lesson. It's very cool.
Okay, I missed part of that. If we went to another planet.
Oh, sorry, Anastasia, did you have a question or you just had a comment that you like this class? I didn't understand it.
I'm sorry, I missed it.
Comment. It's so very interesting. You thought about in the future planet Earth.
What do you think the future of planet Earth is?
Maybe you can think about it and type in the chat.
Yes, planet Earth is going to be fine. I don't like it when people say we need to save the planet. Planet Earth is going to be fine. It's whether humans are going to be fine. There are too many of us. We're eating up and burning up everything on the planet. But the Earth has been through change before. When the dinosaurs were here, the Earth was warmer than it is now. We've been through ice ages. The Earth has been very cold. Some people think there was a time when the entire Earth was covered in ice. So the Earth has been cold. The Earth has been hot. Right now it's just nice. So it changes. But that's what it does. The Earth changes. And every time the Earth changes, we've also been hit by things from space, like the big one that wiped out the dinosaurs. And every time there's a big change on the Earth, life on Earth changes. And what comes back is different than what was there before. So we don't have dinosaurs anymore. We now have mammals, us. So if things get really bad, then maybe we'll go extinct and some other animals will take over. I don't know. But we humans are now in a position where we can take care of things. And we can make sure that we don't change the Earth, because we're now making a change. So let's stop doing that. Let's understand the Earth, understand how it works and how we can live with it so that we don't hurt it. So that means we don't let our numbers get too big. We don't have too many people on Earth, and we live with it. We live with it rather than think we can just take everything. And that also means getting along. So I believe we can do that. I believe we can do that without having the Earth change so much that we can't live here anymore. That's my dream. That's my hope, that we can do that and also get along with each other.
Thank you, Bob. Thank you so much. Then the next question will be from Zahar.
Thank you a lot for your working. And I have a question. Do you think people will die out faster than they colonize other planets because all the Earth's resources will be used up? Because we will not have the resources to survive because all the minerals and the wood will be used up. Thanks.
Well, you're right. We are using up resources. We've been using resources that are not renewable, like oil and gas and coal. But there are other resources that are renewable. Sunlight. Sunlight is free. And we know how to turn sunlight into electricity with solar panels. We can take the wind and we can turn that into electricity. We can take the heat that's within the Earth and use that. So there's a lot of energy around us that we're not using right now that's free. So that's where we need to have the future of where we're going to get our resources, is those renewable resources. And plants, we can keep making sure that we replant trees instead of just cutting them down, but replant new ones. Here in Canada, we have lots of wood. And we cut a lot of it down, but we also plant new trees so that they come back. So we can live in balance. We don't have to just rely on things we dig out of the ground and burn, like fossil fuels. And I wrote a whole book about that called The Future is Now, Solving the Climate Crisis with Today's Technologies, because we already have the technology to live and use energy, but not use up the planet. The big issue is going to be food and water. And that's where we have to control our numbers so that there aren't too many of us taking the food and the water. But I believe we can do that. I think we're smart. I think we can do it in the future.
Thank you for your question, Zahar. Then I guess we can take like 1 or 2 more questions, and then it will be the end of our class. Because unfortunately, we're running almost
Okay.
Yeah. Okay, so Peter, you were the next one.
Hi, thank you for the lesson. I want to ask, how do you think is on Earth from century to century, while it goes round itself, time goes with the same speed, or it goes faster or slower?
As we move through space, our speed around the sun is the same. That will not change. Our speed around the galaxy will not change because the galaxy turns. Takes us 250 million years to go around the galaxy once. What can change a little bit is the sun can get a little brighter, a little dimmer. That can affect our climate. And we also have cycles of the Earth. We're not straight up like this. We're tilted off to one side. That's what gives us our seasons. And there's a slow cycle there that can alter our winters and summers a little bit. So there are natural cycles that the Earth goes through. That's why we have ice ages. We've had 5 ice ages, and we're actually overdue for another one. So the Earth gets warm, gets cold, gets warm, gets cold. And the warm times, like we're in right now, are usually about 10,000 years long. Well, it's been 12,000 years since the last ice age. So we're overdue for another cold snap. But we're not getting cold because we're putting all kinds of greenhouse gases like carbon dioxide into the atmosphere, which is making it warmer. So if we stop doing that, then the warming will slowly start to come back down again. But then if the Earth goes really cold, can we adapt to that? As Canadians, we know how to live in the cold. Excuse me. But maybe for you who live in the South, you might find that a little more difficult. So the Earth will always be changing a little bit. And we have to get used to that. We have to adapt to that. But we have for the last 2 million years. You know, humans have been standing up on 2 legs for at least 2 million years. And we've been living on this planet, and it has changed over that time. And we've managed to live here. So I think we can continue to live here in the future. We just have to be careful about it.
Thank you so much, Peter, for your question, and thank you, Bob, for answering it. So I guess it is the end of our class. So thank you so much, Bob. And I guess David wanted to say something too at the end.
Well, Bob, thank you for today. What a gift you've given us. I just can't help but feel like I need to leave my office right now, go home and grab a bunch of science textbooks and read. So thank you for all the wisdom you've imparted. And for students that are in all these different countries, if you want to hear more from Bob, he actually has a podcast, and which I have it on my cell phone. So if you look for his name and Quirks CBC, you're going to be able to have access to all these dozens of various beautiful, wonderful podcasts that Bob has given throughout the years. And Bob, again, on behalf of all the students here at Smartos Vida from Afghanistan and Myanmar, thank you for coming. What a beautiful gift.
Thank you. And thank you all for joining me today. It was a real pleasure, a privilege for me to speak to you all. And remember, love your planet. It's the only one we have.
Thank you
Bye,
so
everybody.
much. Yeah, thank you so much and for making this class and hopefully see you again in
Okay,
some time. Yeah, so thank you
Okay.
so much. Have a nice day and bye
you
then.
too. Bye-bye.
Bye-bye. Have a nice day.
Bye bye. Save our Earth. Save. See you next time.
Bye.
Save our
Bye-bye.
Earth. Thank you.
Bye.
Thank you so
Bye.
much.